spend hours writing an automation script to pull data from a website. It works perfectly on Friday. By Monday morning, the website developers tweak a single line of code, maybe renaming a button's color class, and your entire script shatters. The root cause of this constant failure is that traditional automation bats are functionally blind. They don't look at the screen. Instead, they scan the underlying document object model, or DOM, the hidden HTML code that structures a web page. If a developer alters that hidden code, the bot loses its target entirely. ByteDance recently open-sourced a solution to this problem called UITARS. Without heavy marketing, the repository rapidly accumulated over 32,000 stars on GitHub, driven by developers looking for a more resilient way to automate tasks. This illustrates the core operational shift. UITARS bypasses the DOM. It operates as a multimodal AI agent that processes the actual screen pixels, icons, and text. The targeting overlay on the right shows how the agent evaluates the visual interface exactly as a human does. By removing the reliance on hidden HTML structures, automation is no longer tethered to web browsers. It can interact with any visual interface, on any platform, mimicking a human operator. The visual perception behind UITARS is powered by the open-source Seed 1.5 VL and 1.6 series vision language models. Looking at this diagram, you can see how these models translate a raw, flat desktop screenshot into spatial data. The system drops coordinate crosshairs over the visual elements, mapping the screen into a mathematical grid to provide the AI with precise X and Y coordinates for mouse clicks and keyboard inputs. ByteDance deployed this engine across two distinct channels. The first is Agent TARS, a developer-focused toolkit. It uses a hybrid strategy, combining direct visual GUI control with traditional DOM reading for maximum accuracy. The second channel is UITARS Desktop, a native cross-platform application for Windows and macOS. You type a natural language prompt, and the application funnels those instructions directly into native operating system clicks and keystrokes, completely outside a web browser. This dual architecture provides surgical, hybrid tools for developers building complex workflows and straightforward desktop control for end users. Clicking and typing is only half the equation. An autonomous agent needs a structured method to exchange complex data. The Model Context Protocol, or MCP, acts as a standardized bridge. A central AI node sends out requests to external tools, like calendars or weather APIs, and pulls the resulting data back into a structured event stream. To protect your local machine during these operations, the system relies on an AIO agent sandbox. This isolated environment keeps the agent's deep thinking processes and tool executions completely separate from your actual operating system files. You can monitor this entire process in real time through the Event Stream Viewer. It displays exact data flow, active runtime settings, and tool call timing statistics, ensuring complete operational transparency. Granting an AI native control over a computer carries risk. UITARS manages that risk by pairing visual freedom with strict, verifiable operational isolation. Once a visually capable agent is established on a single local machine, the next step is extending its reach across a network. This isometric illustration captures the newest feature in the stack, the remote operator. The AI is no longer confined to the local hardware where it was installed. With zero required configuration, the system allows instant remote control of external computers and remote browsers. We are moving away from the process of writing rigid scripts that hunt for hidden HTML tags. We can now issue conversational instructions to an agent that perceives the visual interface exactly as we do. By standardizing how an agent sees and acts across local machines, remote servers, and browsers, UITARS creates a reliable layer for computer use agents. It effectively turns any operating system into a shared workspace where digital assistants can navigate the same